Hi, I'm here to talk about work field forces, right? Yeah, okay, cool. Um, so this is the tier 3 for work, as you can see up here. Da-dunk. Cool. So, our first problem has a couple different parts to it. And remember that work is equal to the forces multiplied by the displacement. Pretty simple, and it's the displacement in the direction of x. Cool. So for our first problem, we'll look at A. So we're going to answer the question, well, does gravity do more work on Bobby or Sally? And the answer is it does the same amount of work. Because work isn't the force being applied or how far Bobby or Sally is moving, it's just the work done by it. And gravity, because they're the exact same mass, means it acts with the same force. And they also move the same displacement by 5 meters, according to question B. So the answer for A is equal work. Now, is work more efficient on Bobby or Sally? Well, that's a question for another day. Cool, so there's that. Part B. If mass m is 75 kilograms, so the mass is equal to 75 kilograms, and the starting height is 5 meters, what is the work done on Bobby by gravity? Is it negative or positive work? Well, here we are. There's 2 points to this. One, displacement equals 5 meters. Okay, cool. So, what is the work done on Bobby? Well, we have our mass. We also have our acceleration because we're talking about gravity. So the acceleration is going to be 9.8 meters a second. And you ask why I don't make that negative. It's because it's in the direction of x. We're moving down 5 meters. We're not dropping 5 meters. We're just moving in that direction, 5 meters. So it's positive force. Now, some quick calculation brings us to 9.8 multiplied by, well, let's see, 75 kilograms is going to be, 75,000 grams-ish. So, and that is, you know what? Yeah, it's in mass. So that gives us 735,000 newtons of force multiplied by the displacement. So 5. Hold on one second. Hey, so, actually no, quick correction. That's going to be 75 kilograms because joules, the unit of work, is in kilograms, not grams. So that is 9.8 multiplied by 75, 735. And then that multiplied by 5 is going to be 3675 joules of energy that gravity is doing, or joules of work, rather, that gravity is doing on Bobby. And the second part of this is it positive or negative work? Well, none of these things are negative. So, of course, we're left with positive, and that's a strict mathematical explanation. But remember, we are moving in the direction of x, or the direction of y. And it's a positive movement. So we're also moving or accelerating in that direction in 9.8 meters a second. So it's not negative because we're not dropping. We're not moving negative 5 meters from here to gravity. We're just moving from here to this point. And so it's positive work, of course. Positive work. Yeah. There's that. Yay! So then let's go to part C. If mass m is 75 kilograms and starting height is 5 meters, what is the work done on Sally by gravity? Is it negative or positive work? Well, alright, so the first part is asking how much work is done on Sally by gravity. And keep in mind that when dealing with work, we're only concerned with work in one direction. That is, this direction. So gravity is going to follow, or the work done by gravity is going to follow the exact same equation that we used with Bobby. So it's going to be 36, I believe it was 75 joules of work, slash energy, slash whatever you want to be. And then that also means that it's the exact same direction. It's not negative or positive work because it's speeding up in that direction. It's not slowing it down at all. So it has to be positive work. Yay! That's the quick and dirty. Or, well, no, it's really not. So here, part D. Now, since Sally is in contact with the surface of the slide, which we'll assume is like this, basically. So here's our slide, and here's Sally, the box, moving down the slide. The normal force will always be perpendicular to the plane that the object is in contact with. And if we remember anything from our videos, it's that when work moves like this, and certainly you remember this from the lab, when the forces are perpendicular to the motion in that direction, say if this is the normal force and this is, well, Sally moving in this direction, there's no work being done here by the normal force because it's perpendicular. It's not moving in that same direction. So the short answer is there's no work being done by the normal force because it's perpendicular to the plane on which the object is moving. So that's part D for you. Now, E. Which one, Bobby or Sally, is going faster when they reach the ground? Well, the short answer is that, well, the slide... Oh, it is a frictionless slide. Well, the short answer is that, well, Bobby is. Because Bobby is moving straight down. He's not being slowed down by anything. But actually, no, that's not the case at all. They're both moving at the same acceleration. So that would mean that they're moving the exact same speed. Ta-da! Same speed. I think that's the case. I wrote down Bobby on my sheet. But now that I think about it, I think that might be the answers. They're moving the same speed because of the same acceleration. Yay! Coolio. And finally, F. Who reaches the ground first? Well, let's think. Bobby, over here, is moving straight down. But Sally is moving down a slide. And ultimately, this is going to be longer than this. And if they're moving at the exact same acceleration, that means that Sally is going to have to travel a greater distance, even though that this is 5 meters down, because she's traveling on this slide. So Bobby is going to be the first one to hit the earth. All right, problem 2. Which requires more work, lifting a 50-kilogram sack of vertical distance of 2 meters, or lifting a 25-kilogram sack of vertical distance of 4 meters? Well, say we don't even know the acceleration. We can use the equation for work. So let's take our first instance, which is, and remember that force equals mass by acceleration. And we know the mass, we just don't know the acceleration. So 50A by, so work equals 50A by the displacement, which is going to be 2 meters. And our other situation, which is work equals, well, let's see, 25A by 4 meters. Well, let's see. Doesn't this simplify out to work equals 100? Here, I'll get rid of the units here. So 100A, because it's commutative? Yes, entirely so. Remember the commutative property, so essentially this is what we're saying. We're not distributing the 2 into there. We're just saying this. And likewise here, where it's 25 by A by 4, so 2 by 50 is 100A, and this is work equals 100A. So short answer is that neither does, because it's the same amount of work. Cool. Question 3. A force of 80 newtons is applied to one end of a lever, which moves a certain distance. If the other end moves only half the distance, how much force does that end of the lever exert? Well, this is a funny one. So here's our lever, right? Now keep in mind that force is only equal to mass by acceleration. There's a bit of blur there. Hold on. Force equals mass by acceleration. And let's say we put down 80 newtons on this side. Well, here's our pivot point. And if that's pushing down on that end, that just means that this is going to move up with the exact same amount of force. Because even though it only moves half the distance, that doesn't affect the force applied. Indeed, the displacement would only affect the work. So the input work would be, 80x, and the output would be, 80x over 2. So force by, the displacement. And that would mean that the efficiency of pushing down on the lever is only 50%, but that's work efficiency. That is not the force being applied. Right? Cool. So, half the work. So work goes in, half the work comes out, but it's still the same amount of force, because displacement doesn't matter. Cool. Alright, question 4. During a tug of war, Team A pulls on Team B by applying a force of 100 newtons to the rope between them. How much work does Team A do if they pull Team B towards them by a distance of 2 meters? Well, hey, let's take a look at this rope here. And here's A, and here's B. Well, let's see. So there is a force of 1100 newtons this way, and they're displaced by 2 meters. Oh, hey, the equation for work is force by displacement. So force multiplied by the displacement, which gives us 2200 joules of work that Team A does on Team B. Yay, so that's taken care of. Alright, question 5, part A. A student removes a 10.5 kilogram stereo amp from a shelf that is 1.82 meters high. The amp is lowered at a constant speed to a height of 0.75 meters. What is the work done by the person? Well, we can't quite answer this quite yet. So we'll look at part B first, and then we can come back to part A. The work done by gravity, or the gravitational force that acts on the amp, is going to be, well, the work equals force by displacement, and the force is mass by acceleration by the displacement. So we can work that out, because we know that the mass of the object is 10.5 kilograms. And we know that the acceleration of gravity is, well, because gravity is actually slowing down the person. Or I'm sorry, it's moving in the direction of x, because direction of x is this way. Yay! So we know that it's going to be 9.8. Oh, wait. No, I'm sorry. This is actually negative work. Gravity is doing negative work because the person is applying for, well, okay, 1.82 meters, 7.75 meters. It's moving down. It's not moving in the direction of x. Direction of x is, or direction of x/y is this way. So what this means is that, gravity is moving it down. It's negative. So negative 9.8 by our displacement, which is going to be 1.82 minus 0.75, which is going to be 1.7 meters, the displacement. And this works out to be, well, 10.5 multiplied by negative 9.8 multiplied by 1.07. That is negative 110.103 joules. Cool, so we have part B solved, but we don't know how part A is solved. Well, let's look through it real quick. Alright, so bam, 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 bam. Oh, wait. The question says that there is a constant speed. Or, well, yeah, constant speed. And if it's a constant speed, that means that there's no acceleration. And because there's no acceleration, that means that the forces acting upon this amp are going to be exactly equal, but opposite, of course. It's going to be the conjugate of this. So, because there's no acceleration, that means that the work done by the person, or part A, is going to equal the opposite of the work done by gravity. Because remember, we're not talking about forces. In fact, we're just talking about the work done. So, what's the simple answer? If it's going to be the exact opposite of this, then that means that the work done by the person is going to equal 110.103 joules. And this keeps it moving at a constant speed because it's equal work. It doesn't have to deal with the forces involved that the people, or that the person in gravity are using. Cool. Question 6. Person pushing a 16-kilogram shopping cart at a constant velocity for a distance of 22 meters. She pushes in a direction of 29 degrees below the horizontal. A 48 Newton friction force opposes the motion of the cart. What is the magnitude of the force that the shopper exerts? Cool. So let's draw a little diagram first, actually. So here's this, this, and this is 29 degrees. We also know that, well, there's a 16-kilogram shopping cart, and it's also moving at a constant velocity. This way, I believe. And it's for a distance of 22 meters. So, I'm going to pause the video while I work this out a little bit. Okay, let's do the simple part first, actually. Well, let's look at part D. How much work is done by the gravitational force? None, because it doesn't have a displacement that is creating. And it's in a completely opposite direction as well. So the work done by the gravitational force is 0. Yay, that's done. And then let's look at C, the friction force, which, if you remember in this diagram, is moving this way at, or, well, no, it's really not. It's over here. It's at 48 newtons. Cool. So, or, well, we know that, oh, god damn it. Okay, so 48 newtons, and the displacement is 22 meters, but it's also moving in the opposite direction, so 48 newtons by negative 22 meters, and because it's slowing it down, so the work done by the friction is going to be negative 1056 joules. Cool. So, given that information, let's take a look at B. Well, B is going to have force equals, or, well, work equals force by the displacement, which is 22 meters. is going to equal 1056 joules. And I'll pause this here and pick this up in the next video because the bell did just ring. So I'll come back.